No, it's true. I mean, he sort of wears it as a badge of honor, which I like. So today, talk about hierarchical ANOVA. We may get to Latin squares too, because these are not long things. There are also things that you should avoid, like the freaking plague. Run for your lives. I'm doing this with a sense of completeness. It's not like I like hierarchical designs at all. I despise them with every fiber of my being, with the intensity of 1,000 suns. Usually all of our factors are independent variables, in other words, are crossed with each other. They interact with each other. All levels of A occur with all levels of B. Right? That kind of thing. And I'm not talking about subjects, we talk about nesting with subjects. That leads to either independent groups or repeated measures, that's fine. Subjects, of course, are often nested. That's not what I'm talking about. Sometimes, however, things are different and scary. Well, that's a little scary. For interpretation purposes, as you'll see in a moment. Okay? So sometimes things are a little bit different. Okay. What we have here, this design, and this is actually from a real research project that a friend of mine did statistical consulting. One of the ways you can make a little bit extra money in graduate school if you are good at statistics is charge people money to analyze their data from other departments. People doing medical research very often. And I will tell you the story of my doing that a couple of times, probably next time, because it's more pertinent the next time. But my friend Todd was asked to analyze these data, and we have hospitals, 3 different hospitals, this was in Toronto, and we have 6 different painkillers. We have independent groups that are burn survivors. So these are people that are in a great deal of pain. So trying to develop and test new painkillers for people that are in literally constant pain. It's a sad story, but if you can get a better drug, that's wonderful. Now, the thing is, the way the study was designed, they just had 6 drugs, they had 6 groups, they thought they had a nice independent one-way ANOVA situation, and they don't. Because hospitals also make a difference, because each hospital has a different staff, each hospital has a different environment. You have to take hospitals into account. Because if we get a difference between these drugs, maybe it's because they're administered at different hospitals. Right? See the logic there? And this is what Todd told him. He said, I'm sorry, I can't just analyze this with a one-way ANOVA. You have to do it this way. So we get 5 burn survivors in each group. So things are weird here because we've got hospital, which has 2 degrees of freedom. And it's a between factor, so it's between subjects and data. And then we go drugs within the hospital, D-1 times H. You're going, wait, there's 6 drugs. Yeah, but there's within each level of hospital, there are 2 drugs. 2 minus 1 is 1 times 3. Okay? And then we've got subjects within drug-hospital interactions. You can't say subjects within drugs within hospital. It just doesn't work that way. So both of these effects, the effect of hospital and the effect of drug within hospital, are tested. So you divide by mean squared for drug within or for subjects within drug-hospital interactions. So there's not subjects within drugs within hospital. You just don't. That's not a thing to say. And I like to think of it this way. The subject or the group looks up and sees a drug-hospital interaction, but can't see over here. Can only see up, can't see the other cells. So they don't know. So I think of it that way. So to them, it's a drug-hospital interaction. Because they don't know what's going on over here. So there are cases where this is going to be useful. And this is one of those cases where, and it's usually a field thing, and it's where you have You have to take this other variable, in this case hospitals, into account. You really can't intellectually not do it. Because if you found a difference, what if it's due to a hospital? And also, you want to remove this variation. This is the best thing you can do. But your conclusion is drugs within hospitals are different, not that drugs are different. Right? So you're saying there's an effect of drugs within each hospital, if there's an effect. And there was, actually. And Todd said, you really should do this differently. These people should all be in the same burn ward, and they said, we can't do that. We don't have the beds, we don't have the resources to do that, it just can't be done. And they said, okay, well, this is the best I can do. I'm sorry, this is the best I can do. Right? Which didn't please them, but he said, you got to do it right. And then he put his $1,000 in his pocket. It's the ending story. But I mean, you can actually, literally, if you're a psych student who's good at stats, you can make a little bit extra money in graduate school anyway. So keep in mind. Okay, questions? You see the logic of this? Yeah? Okay. Here's another example. We'll say n equals 3 here. Whoa, look where that came in. So we've got A, we got B, we got C, that's 3 now. This is going to be a little more complicated. Let's put it over there. So now we have nesting as well as within subjects variables. Now this gets complicated. Yates order is your friend. It will tell you what to list when you're trying to figure out the source of variation and the degrees of freedom. Order is, looks like it should be a word, it's not. It's order is. What are the between subjects variables? Where different subjects get different levels of the variable. Do we have any between subjects variables? Looks like everybody gets every level of C. I think that's a within subject variable. Right? Because 1, 2, 3, 4 gets C1, 1, 2, 3, 4 gets C2. So C's a within subject variable.
Is it D?
Is it which?
B?
B is one of them, I think.
Yeah.
Different subjects get B1 or B2. Yeah, B's a between subject variable. What's another between subject variable? A. A is for sure, because different subjects get different levels of A. There's also a problem here that we have nesting. So we have, and what's the nesting situation here? Besides the subjects, what's the nesting situation?
So you would have subjects and then A nested in subjects.
No. Don't worry about the subjects here.
Oh.
Just worry about the factors themselves, the independent variables. Because we have nesting here. This is a hierarchical design.
In C, right?
No. That's okay, you should try it.
Okay.
I appreciate it. Take a look at this. Where do different levels, do all levels of C occur with all levels of A? C1, C2, all levels of A. Yeah, all levels of C occur with all levels of A. That's good. So C's not nested with anything. Right, because all levels of C also occur with all levels of B. So we cannot, C isn't nested. C is just a within subject variable. That's nice. Let's look at our between, RJ. What about A? Nested how? Is A with, don't worry about the subjects. Yeah, don't worry about the subjects. Look at levels of B. Does every level of B occur with every level of A? No. Some levels of B occur within A1, and some levels of B occur within A2. Right? Does everybody see that? Yeah? Okay, I see some nods. All right, I'm feeling them. I don't really see that well. Thank you. Blind joke, it's offensive. I make blind jokes and autism jokes. Put them together, it's great. John and I, we read a tandem bike. We do. John's not good on a bicycle. Like, I think he just stops paying attention, starts thinking about plane crashes, and then falls over. So we got this tandem bike, which is great. And two guys, John's about as big as me now, two guys our size going down any kind of incline. We're going 50 kilometers an hour. It's amazing. But it sounds like a joke, doesn't it? This blind guy and this autistic kid get on this tandem bike. We're definitely going to a bar on his 19th birthday, just so I can walk into a bar and go, this blind guy and this autistic guy walk into this bar. I told him that, and he's like, I don't want to go to a bar. It's like, you will when you're 19. Anyway, back to where we were. B is nested within A. Different levels of B occur within different levels of A. You can talk about A on its own. You can't talk about B on its own. Right? Look at that. You can talk about A. You can say, sure, A goes with C, A goes with B, if we're fine with A. But you can't talk about B on its own without mentioning what level of A it's in. That's sort of the test to see if something's nested. Can I talk about B without mentioning A? No, I can't. It's impossible. Whereas Ralph Wiggum would say it's impossible. So the final little bit of Yates' order is you go between subjects within, but you start with the top of a hierarchy. So the non-nested, then the nested. Okay, so let me show you the source of variation degrees of freedom table for this. We got A. We can talk about A on its own, so go between subjects within. A is a between subject variable. B is a between subjects variable, but it's nested within A. And C is a within subjects variable. And now it just is do that thing that we do. A, this is the easy degrees of freedom, has A minus 1. So there's two levels of A. B within A, because you can't talk about B by itself. You have to say B within A. B minus 1 times A. There are, within each level of A, looking at that design, there are two levels of B. So 2 minus 1 is 1 times 2 times.
Why can it not be vice versa? But A is first.
Because you can talk about A on its own. If you look, think of it again. Think of it like the variables look down. Okay, or they look up. When A looks up, it doesn't see anything because it's first. It's the top of the hierarchy. Yeah. So when A looks up, it can't see anything, so it's on its own. When C looks across, it doesn't see anything. It's not nested. When B looks up, it goes, oh, there's an A1 there, or an A2. He's cooking something. It smells kind of good.
Pasta.
Yeah. Something with tomatoes. What's going on? I should put one of those little induction burners in my office. I cook all kinds of fun things.
Oh.
My wife says I should be cooking Chinese dumplings in my office. Because I can. I'm really good at that. Making dim sum. I said I think that the people... And she says I should sell them. Because I think the Morningstar people would be...
Or you could just give them to your stats class. I mean, like...
Yeah, there you go. Maybe I'll make a whole bunch of dumplings one day and bring them in. Okay. Probably not. Yeah, sure.
Well, my mom, because we have Chinese homestays, so
Okay.
she makes pork, chicken, beef.
It takes some practice, but I can do it now. You best to actually do it without looking, because if you look, I find if I look, I screw it up.
Do you do it on a steamer?
Yeah, I have a steamer, and then I can fry them.
Yeah.
I have a big metal steamer, and I have a bamboo one. I have so many woks that there was the other day. I have all my pots hanging up in my kitchen. I looked and I went, I didn't even know I had that wok. I'm a complex person. What did that even mean? Subjects are nested within A-B interactions. Okay. We had, how many subjects did I say? It was it 3? Something like that?
Oh, yeah.
Is that right? Yeah. N minus 1, so 3 minus 1 is 2. There are, within each level of, within each level of A, there are 2 levels of B, and there are 2 levels of A. So we go 2 times 2 times 2, we get 8. Well, that's good. The betweens are done. Now we'll do the within. Oh, it gets a little easier now. C. Oh, that's easy. And then we go C by A, C by B within A, C by S within AB. Done. Can't cross C with itself. What do you test with what? Well, that's that one column there, the test column. We're going to test A and B within A by the subjects within AB term, when we do the analysis variance. Same thing here, C by A, C by B within A are all going to be tested with the mean square for C by S within AB. Analyzing these kind of data with SPSS is really not tremendously easy. It can be done, but for some reason, SPSS comes out by calling this an AB interaction, an SAB interaction, a CBA, and they really aren't. They don't have the nesting. And I don't know why it's like that. There's even a little note on the SPSS page when you look and talk about hierarchical designs and says, oh, we don't do it that way. You mean the way everyone else in the world does it? It really annoys the hell out of me. So that's, frankly, if you ever, first of all, you're never, no one will let you design an experiment like this. But if you did, I would say go learn R. Don't use SPSS at all. Right? Or SAS, which is much better. SPSS will do it, it just comes up with really funny notation that doesn't make sense, that's all. But if you wanted to do nested design for your honors thesis, we wouldn't like it. Your advisor would go, no, I'm sorry, you're not doing that. We'll find another way. Questions? Okay.
I have a question.
Oh, good.
For B minus 1, why is it the B 4 minus 1?
Because within each level of A, there are just two levels of B.
Okay.
Just like you do with the subjects when you have nesting. It's kind of hard to get your head around that, again, unless you realize that within each level, you don't know what's going on over here in the hierarchy.
Level A1 has B1 and B2.
That's right. Within each level of A, there are two levels of B. That's why the B minus 1 is only 1 in that case, not 3. Yeah, good question. Other questions? You know, you should be able to go the other way too. Let's see if we can do this one. Yeah, let's do this one. We'll do this one up on the board here, but you will tell me what to do. I mean, within reason. Okay. This would be the kind of thing that would show up, perhaps, on the final exam, he said knowingly. Okay. There will be one like this, where you will be given this, not this actual one, or maybe it will be this actual one. And your task will be to show me the design. As Tom Cruise said, show me the design. No one ever said that. What a cultural reference from the 1990s. Okay. Look at this. Between subjects, what's the between factor? Or the between factors? Maybe there's more than one. Tell me what the between factors are, or if there is one. Between subjects within. Remember that. B's a between factor. How many levels does B have?
3.
Yes. So we can start by going B1, B2. Ooh, look at that. It's starting to take shape already. It's like when you build a model plane, man, you put the propeller on the engine. What a very bad analogy, because I'm sure no one else in here ever built model planes. Okay. Did anybody build model planes? No? Okay. I used to. Kind of get back into that. Anyway, that's beside the point. So, and look, this also tells you subjects are within B. It must be a between subject factor. That's good. Do we have any within subject factors? A. How many levels does A have?
3.
Yes. Is there any nesting of factors, not of subjects, of factors? No, because we don't have A within B or B within A. So we don't have to worry about that crap. Good. We have 3 levels of A. They're crossed with B because there's no nesting. A. Subjects are within B, and B is a between subject factor between subjects within. We've already established that. So, within each B1, we've got group 1, group 1, group 1. Within each B2, we've got group 2, group 2, group 2. And here we've got group 3, group 3, group 3. Almost done. How many subjects are in each group?
430.
Pardon me? How are you getting
36 divided by,
Yeah, no, that's right. That's one way to do it.
by 9.
36 divided by 9. There are 9 cells. There are 36 total observations. 9 times what equals 36? 4. 8 equals 4. Hey, 10 out of 10. Not so bad, right? You know the beautiful thing about this is, these are easy to make up practice ones to do. Make up a design and break it down. It's easy. There.
How do you get the end again?
How do you get the end? There's a couple of ways to do it. One of them is to take a look and just say, what Amy did, which is pretty smart, which is to say that there's 9 cells, 4, 5, 6, 7, 8, 9. There are 35 degrees of freedom, so there's 36 observations. 36 divided by 9 is 4. So that's one way. The other way is to take a look here. It goes S within B equals 9. Right? S within B equals 9. That means n minus 1 times B equals 9. N minus 1 times 3 equals 9. 3n minus 3 equals 9. 3n equals 12. N equals 4. Algebra. That'd be the other way to do it. In fact, I would do them both. I would do it both ways just to double check this. Right? And I know doing problems like this when I was in school, these kind of things, I would always do it both ways just to double check. Because those two things should agree. If they don't, you've done something very strange. See, so that's not that hard to do. And this, in fact, literally is something that I do whenever I read a paper. I look at the analysis, they use ANOVA, I look at the analysis of variance. It allows me to then figure out the design without having to read the method section. And if I read the method section and it's different from this, I go, either I'm misunderstanding something or somebody did something wrong. Right? So this is actually useful that way. Questions? So that's not so bad, right? It's not so bad. Where am I? Where'd my pointer go? There it is. Okay, things to remember. Using Yates order, you can figure out any design in the error terms. It always works. It never doesn't work. Now, going back to these hierarchical designs, we have a little problem here, though. Is hospital a fixed factor or a random factor in our original example? I don't know. I think I'd probably consider it a random factor. Yeah, I'd probably consider it a random factor. Avoid these things like the plague if you can. Like literally just think it's like the movie Invasion of the Body Snatchers and you're going, oh, like that, and it's Donald Sutherland pointing. Nobody here seen that movie. It's the big Sam scene. No, she just thought it was funny. Going, oh. Okay, so that's not so bad, right? Okay.